Hi. So now we're going to talk about how to set up a HomeLab using Terraform or OpenTofu. This is going to use Libvirt for the provisioning of VMs, and for the UI itself, I have Cockpit, which is, I guess, UI for Linux. And as you can see, I have about 128 CPUs and 240 gigs of RAM. Let's talk about the components that are involved here. Uh, this represents our uh, virtual machine host. It's going to have two bridges. Basically, the first one being bridge 0. It will have a IP address from our primary router, that is the 1/24 network, and we're going to assign it some address 1.100 in this case. I think that is already created. Yep. We already have a bridge with an IP address from a WAN router. Now let's talk about. Now let's. I'm sorry. Let's create the switch now. Switch 0. Yeah, we're going to enable STP. And what we're going to do, we're going to disable the IPv4 and IPv6 assignments because we don't really need them. Okay, so now we have the bridges ready. Then we need two bridges because so the first bridge, any network interfaces from any of the VMs that end up in this bridge are going to have an IP address from a primary router, and we create a second bridge because for the OpenShift virtual machines, just to have a private network for some of the components that we're going to have. Yep. Now let's talk about the infrastructure components. Let's start with the router first. Okay, so as you can see, the router has two network interfaces. The first one, which is attached to the bridge, so it's going to get an address from the WAN router. It can get an address, but we're going to configure this manually. We're going to see this when we configure the router. And this is also going to be the router for this domain. And when I mean this domain, I mean the broadcast domain of this bridge. So for all of the virtual machines that have an address at the 16.0/24, which are in that network, this is going to be the router for these machines. And we're also going to have containers VM. So this is going to be a generic virtual machine which is going to have some Docker containers. So OpenShift requires an external load balancer, and that load balancer is going to be hosted here as a Docker container, and it would have two network interfaces again, one for the external network and one for the internal network. Along with this, we're also going to have pull-through caches because so the OpenShift nodes are going to reach out to the internet to pull any Docker images, and since we're going to have a lot of these VMs, it makes a lot of sense to have pull-through caches configured so that any image pulled from outside is cached onto here, so that the nodes can pull from these caches instead. Let's take a look at the requirements now. So your Libvirt configuration needs to look like this. You have to change this because otherwise you won't be able to create the VMs without root access. And okay, so for the router you need BIOS ISO. This is going to be the base image for OpenShift VMs, and we have Alma Linux. Alma, you can have any enterprise Linux 9 image, but I'm using Alma here. And for OpenShift, we need two binaries. The first being OpenShift install, and then the OC binary, and then we're going to create a install config.yaml, the OpenShift configuration. Great. So let's start with creating the router first. So I already have the ISO file here, and if I go to the cockpit UI, let's not talk about this machine. Let's just pretend it's not there. So we're going to create. Okay, so let's take a look at the driver program. So this is a small utility that I wrote that will help you to create the modules here. So we're going to start with the router, and I'll expect it to fail because we have not actually initialized the. Yep. So let's wait for it to initialize and then. Okay. So now if we try to apply the router module, yeah, it's going to work fine. Now let's talk about the variables that you can change for the router. So like I said, our external bridge is the bridge 0, is bridge 0 that is connected to our WAN router, and the internal bridge is switch 0. And for the router virtual machine, two MAC addresses for two interfaces, the internal interface and the external interface. The internal interface being attached to the switch 0 bridge, and the external MAC. This interface is going to get attached to bridge 0. Pretty sure you don't really need this variable, but yeah, that's fine. So let's create the router. Okay, so now if you go back to the cockpit UI, okay, we'll see the iOS machine. Now let's boot into this ISO. Okay, so now we're in a shell. Let's log in. I think the default password is YOS. Okay, now we're going to install the image onto disk. Yes, let's name it 1.5. Yeah, that's fine. Console. Yes. Okay, so now YOS is installed, but now we need to power off, and we'll eject the ISO image which is attached as a CD-ROM, because we don't need to, we don't want to boot into it again. Okay, so we have now booted into the installed image. Yeah, let's wait for it to come up. And remember, we have two network interfaces, one from our internal bridge and one from the external bridge. But we won't have an IP address because YOS doesn't it doesn't have DHCP enabled by default. So we're going to have to assign those addresses manually, which I'll be doing it right now. Okay, so let me log in. Config. I think it's at 0. Wait, let me check. Okay, it is at 0. Set interfaces Ethernet at 0. And we're also going to enable SSH so that we can get into this virtual machine from any machine on our network. Set service SSH. Now let's commit in these changes. Okay, so now we are connected to a virtual machine host. Let's try to get into the router. Okay, so we are able to get into the router. Now we'll execute a script which would it's going to create the necessary configuration for our OpenShift cluster. You can we're going to create NAT rules and then DHCP configuration, DNS configuration, all the fun stuff. So let's copy this, paste, save this, make this executable, and then okay, so this failed because we did not change this variable. So let's try to well, it's not complaining now. That looks good. Let's reboot the machine. Now, yeah, our router is now rebooting. Let's wait for it to come up. Let's get into the router again. And let's check if the configuration is still there. Okay, so it looks like the configuration is fine. And what I'm going to do is I'm going to ensure that our virtual VM host is going to use that VM as a DNS server. So, for example, okay, that looks good, because what we did here is we ensured that for any DNS queries, it reaches out to the YOS router instead of any other server. Don't change it directly from etcresolve.conf. Instead, try to change it from network manager. But yeah, this is just a demonstration. Now we have the router set up. Now let's move on to the containers VM. Yeah, now let's talk about the containers VM. We have a basic virtual machine using the Terraform provider for Libvirt, but we have some configuration information presented to the virtual machine as in the form of cloud init configuration, and those variables are going to come in directly from the root module, and those include information like the host name, the domain name, the SSH key that is authorized to get into the virtual machine, and also some network network configuration. And once the VM is created, we also have we also need to render the Terraform templates for the Docker images that we're going to use. So if you remember, I talked about the external load balancer for OpenShift. That is going to be used as a Docker container, but yeah, so the variables are all going to get rendered using Terraform into something again, which is set in the root module. So once that is done, we also create some self-signed certificates for our proxy caches. We have, I think, 6 of them here for Quay, for the Docker registry, and finally the OpenShift registry. Yeah, I think we have 6 proxy registries set up, and because we need because they're going to use TLS, we will have to generate self-signed certificates. Yeah, that's pretty much it for the containers module. Oh, why do I have that's my home. I don't even live there anymore. Anyway, so I think we only have the router as of now. Let's try to create the containers machine. Now we'll wait for it to complete. Okay, so now the containers machine is up, but let's try to get into the. I know that the IP is going to be 1.250. Okay, but I would expect Cloud Init to run for some time before it is done. So if I, yep, so we'll have to wait for it to complete. It's going to install uh, stuff like uh, Docker, and then it's going to update the existing packages and stuff. Anyway, so this Docker services generator folder is going to have the Docker services generated from the template. So remember, in the template we had variables. Like here we have variables, and then Terraform will render these variables into these things. So that's fine. Now, yeah, and these are the certificates that were created by Terraform again. Let's wait for Cloud Init to complete. I think the log location should be. Is it output? Oh yeah. Okay, let's wait for it to complete. Well, I think I forgot to talk about the variables for the containers VM. So again, the internal MAC, the external MAC, internal IP, external IP. DNS server is going to be set to pointed to the YOS router, YOS machine that we created earlier. The username, the domain name, the host name, and please ensure that you create an SSH key and you provide the path to it, and ensure that the SSH key is not password protected, because otherwise Terraform won't be able to copy the generated Docker images or the Docker services onto the virtual machine. And these addresses are for the Docker services that are hosted on the containers machine. The first two are for the external load balancer for OpenShift, and then we have multiple addresses for the proxy caches. So they are going to those are the ones for the respective registries: Quay, Docker, Kubernetes, and stuff. It looks like our containers VM is now ready. So the Cloud Init status would it says done, but I won't be able to run any Docker commands without root. I'll have to exit out and then log in back again. Okay, so that looks good. Now let's cd into the directory. So we need only two services from here. Let's ignore these things. So let's start the OpenShift proxy first. And you might run into this issue where it won't pull the images, and it's going to error out with some error. Apparently it happens because of MTU. So what I'm going to do is, for the Eth1 interface, I'm going to lower the MTU from 1500 to 900. So let me get into Ethernet 900. Okay. Back. Reapply device. I think it was device reapply. Oh, there we go. So, yep. Now we have lowered the MTU for our internal interface to 900, and now let's try to bring up the service. Okay, so it's able to pull in the Docker image now. And we'll now start up the proxy caches. Great, so I think all of the services are up. We'll exit out of the containers VM, and now we'll proceed on to the fun part, which is OpenShift. Before we do that, let's just confirm that the two Docker services that we have, or the load balancer and the proxy caches, they work fine. So what I'm going to do is I'm going to access the status page for this load balancer. So since this is a HA proxy deployment, it does expose some. Yeah, there we go. So it looks fine, and we also need to ensure that the proxy caches are working fine. So what I can do is so there we go. So it looks like the DNS resolution is fine, and even the cache proxy caches are up. So yeah, that's it for the containers VM. Now we're going to move to the fun stuff. That's OpenShift. Okay, so we have the router setup and containers VM setup, almost there, but we'll now talk about the OpenShift VMs. So OpenShift VMs are going to use ignition configs, and we're going to generate them using a script or a Terraform module. Yeah. So before we do that, let's just validate that all of the necessary DNS records are present in the router. So if I cat my resolve.conf, I'm using the YOS router that we created earlier, and the DNS validator module is it just runs NS lookup on all the records that we need. So let's try that out. Yeah, so as you can see, all of the necessary records are present, and we can now move on with the installation. So okay, so I guess we'll have to generate a config now. For that, before we do that, we're just going to ensure that all of the prerequisites are present. So we have the CoreOS image, and we have the required OpenShift binaries. That's OC and OpenShift install. So binaries, and if I check the version, it's 15 SEOS, and I would expect the OpenShift install to have the same version as well. Yeah, that's the same. Now before we generate the config, so we'll need to create an install config.yaml file and OpenShift configs, and yeah, it's just a simple install config YAML, except for the part where we'll add in our SSH key, so that we created earlier. Public. Let's see. Yeah, this should be fine. G98 9G8. Okay. So, and also we're going to replace the. So, since OpenShift is going to use a proxy or pull through caches instead of reaching out to the internet for the Docker images or the container images, we'll have to use, or we'll have to paste in the CACRT from that was generated for the containers VM. Docker service is generated, and then proxy cache CACRT. I think this is the one. Let's try this out. Yeah, we'll fix the indentation. Let's see. Yeah, that looks good. And now we're ready to generate the ignition configs. So I think under the OpenShift generated file, we have some ignition configs, but those are going to be empty. because those are created by the driver program. So, but now we need to generate the real ignition config. So let's try that out. Config generator. Okay, so now it has generated the ignition configs for all of the machines, the bootstrap machine, the master machines, and the worker machines. So all that is left to do is we'll now create the machines themselves. So let's start with the bootstrap machine. And then the master machines. And then finally the worker machines. Do keep in mind that I have some more storage devices attached to the worker machines because I like to run a Ceph cluster or a rook cluster once the cluster is up, but that's up to you. You can remove them if you want. Now we'll be able to see the master machine, the worker machines, and the bootstrap machine. So we are interested in the bootstrap machine as of now. So let's so we want to run this module so that it approves all of the certificates. And we'll keep it running, and then we'll open another shell, and we're going to run the wait for install module. And while it's doing that, let's wait for the bootstrap machine to come up, and then we can SSH into this machine, and we'll see what's going on there. So it looks like it's coming up. Yep. And as you can see that it has an address of 16.11. So let's try to SSH into this machine. The username is core. Yes. Okay, so I'm able to get into this machine. So you'll see Fedora Core OS here, but once it is pivoted onto the new image, you'll see it changed to CentOS. I think it's SCOS, Stream Core OS, something like that. Anyway, so as of now, we're interested in 2 services. So let's check the status for our it's release image. Okay, so it's now pivoting onto the it's getting the latest image to pivot on, so that's fine. So it looks like our OpenShift cluster is up. We can see that the OpenShift wait for install module has completed. So if I run this again, it outputs an IP to the OpenShift console. One thing to note is I've already changed the DNS server on my machine to point to the YOS router, just because I want to access the console, and the DNS records for it are present on the YOS router. So let's get into the I'll just log out from here, and then so the username is cubeadmin and passwords here. Great. So the cluster is up and running. It's working fine. One thing that's left to do, however, is remember the proxy caches that we set up. So currently we're not using the proxy caches to pull in the container images from, but rather we're pulling it from the internet. To change that, we have a couple of Kubernetes resources that we can apply. One is the digest mirror set, and the other one is the tag mirror set. So both of these resources are going to instruct OpenShift to use proxy caches and to never contact the source. So let's apply them. We do have the OC binary here, so let's export the path. Let's set the path to point it to that folder. Okay, and we also need the cube config that's going to be generated, I think in the generated folder. Yeah, there we go. So it's generated. Now if I run OC get nodes, that did not work. Why not? Oh yeah, the path is wrong. It should be auth. Okay, so there we go. So we can see all of our OpenShift nodes right out here. Let's apply the those two resources that we talked about earlier. Extras, and so now OpenShift is going to change, or it's going to let's exit out of this one. So it's going to create machine configurations for all of the nodes. So we'll wait. Yeah, you can see that the status for the configs has changed from false to true, so it's going to update all the machines. We can insert a watch, I guess, and one by one all of the machines should be updated to use the proxy caches instead. So let's wait for it to complete. Okay, it looks like all of our machines are now updated with the latest configuration. So let's try to get into one of the worker nodes and check the registry's configuration there. I'll drop into a root shell, and then I think it's containers registries.conf. Okay, there we go. So all of the registries are now blocked, and instead of reaching out to the primary source, we are going to reach out to an internal proxy caches instead. So that's about it. We have a fully functioning OKD cluster or an OpenShift cluster up and running. No issues with it as of now. Yeah, that's it. If you like the video, please let me know if you did not like the video. Yeah, thanks for watching. Bye.